Many of the best experiences in gaming, particularly when it comes to indie games, are accompanied by brilliant music and sound design, enhancing both the atmosphere and gameplay itself. So, with that in mind, how do we go about using audio within our own Godot games? Well, it takes three things: some form of audio stream, an audio stream player to control the playback of said stream, and an audio bus to actually process said playback and push it to the speakers. So let's go over these, starting with audio streams, of which there are 6, with only 4: audio stream MP3, audio stream OGG Vorbis, audio stream sample, and audio stream random pitch actually being relevant to this video, with the first 2 being drivers for the MP3 and OGG Vorbis audio file formats, and sharing 2 variables you need to know about. Loop, a bool that determines if the audio will continuously repeat, and loop offset, a float that determines how far into the stream in seconds the repeat will start from. This offset can be great for skipping song intros and such. These can, of course, be modified within the inspector or at runtime through a script, but neither wave modification will be permanent. Instead, you'll have to go to the import tab for the specific file and change the variables there in the way you want, and then re-import said file. After doing that, the changes will be permanent. Following those is audio stream sample, the driver for the wave audio format. This has 6 notable variables, 3 telling the driver how to read the audio. Starting with format, an enumeration representing how the audio is encoded, with 0 being 8 bits, 1 being 16 bits, and 2 being IMA ADPMC compression. After that is mix rate, an integer representing the audio sample rate, and stereo, a bool that of course dictates if the audio is stereo or not. And the other 3 control how the audio loops, with loop begin and loop end defining the points where the audio would loop to and from. Take note that these points aren't in seconds from the beginning, like with the previous streams, but in samples from the beginning. And loop mode, an enumeration with 0 being disabled, 1 being forward, the audio will play normally in loop, 2 being ping pong, the audio will play forwards until hitting the loop endpoint, then play backwards until hitting the loop begin point and repeat, making the audio literally ping pong back and forth. And 3 being backward, the audio plays backwards and loops. Just like before, any changes you make to these variables within a script or the inspector aren't permanent, and you'll instead have to go to the import tab for the specific file and change things there. But, unlike before when it was the same set of variables within the import settings, we instead have 3 categories of unique options. So let's dive into these, starting with the force category, all of whom force the audio to be read as if it were of the given attributes, with 8-bit making the audio 8 bits, mono making stereo audio mono, and max rate forcing a maximum sample rate. These are effectively how you permanently change the format, stereo, and mix rate variables. Next up is the edit category. These all modify the way the audio is played, with trim cutting out the periods of silence at the beginning or end of the audio that is sometimes added by some digital audio workstations. Normalize, of course, normalizes the audio, and loop makes the audio loop. An important thing to keep in mind is that we only have the option to make the audio loop forward. The ping pong and backward modes aren't available, nor are the loop begin or end variables. If you want to use these special settings, you'll have to do so through a script, or go outside the engine to an audio workstation like SoundForge and actually bake those settings into the audio itself, which Godot will pick up on. After that is the compress category, with just one option, mode, which is either no compression or IMA ADPMC, with the former option meaning the stream will take slightly more memory but less CPU, and the latter being the inverse. And that leaves us with the last relevant stream type, audio stream random pitch, which is more of a modifier than an actual stream itself, as all it does is randomly change the pitch of whatever other audio stream you plug into it each time it's played, with its first variable being said stream, and the second variable being the maximum intensity its pitch can be modified to. This can be really good for making repetitive sound effects, think something like footsteps, from annoying the player. Also, one other thing I'd like to mention is that all 4 of these share a single function, getLength, which of course gets the length of the stream in seconds. Alright, so before moving on to audio stream players, I think it's important to talk about why you would want to use any particular audio format over another, kicking off with MP3 and OGG Vorbis. Both are compressed audio formats, meaning that they have very small file sizes at the cost of a notable CPU overhead on playback. This makes them perfect for background music, ambient noise, and other large pieces of audio that are rarely played together. OGG Vorbis is the standard due to its stronger compression, resulting in smaller file sizes and better sound quality, along with the fact that MP3s have a slight pause at either their beginning or end, making it harder to cleanly loop them. That said, MP3s do have their niche when targeting HTML, mobile, or other platforms with limited CPUs due to being less demanding on the CPU at playback. WAV, on the other hand, is a raw audio format with no to very little compression. This causes WAV files to be very large, but very easy for the CPU to read, making them perfect for small sound effects and other pieces of audio that you're likely to be using constantly and playing many of at once. Okay, and now with all that covered, we can move on to the next link in the chain and talk about the node responsible for playing your audio, the audio stream player. Starting with its set of variables, first of which is what we just went over, the actual stream the player will play. The only thing of note with this variable that hasn't already been covered is the fact that you can change streams at runtime. If audio was already playing when you do this, it will stop and the new stream will play from the start. Beyond that is the volume dB variable, a float ranging between -80 and 24 with 0 being the default that modifies the player's volume in decibels. Now the decibel scale is a subject all unto itself and a bit beyond the scope of this video, but the important things to keep in mind are that 0 in this context means the audio will play at its regular volume, and increasing the volume too much via this variable can cause a type of audio distortion known as clipping. So make sure not to push this variable too high if you feel the need to change it at all. And following that is pitch scale, a float ranging from 0.01 to 4, which, of course, scales the pitch by effectively being a multiplier for the audio stream's sample rate. After those is a set of 3 variables, the first of which, autoplay, causes the playing variable to be true when the player is initially added to a scene in-game. The second, being the aforementioned playing variable, toggles if the audio is or is not playing, including when in the editor, hence why autoplay is needed. And also, each time this is toggled off and on, the audio will start over. That's where the third variable in this set comes in, stream paused, which is the pause toggle. A thing you'll need to remember is that changing audio streams won't automatically unpause the player. And finally moving on from there, we have mix target, an enumeration which determines what sound channels the audio will play on, with 0 being the first channel, aka stereo, 1 being all surround channels, aka surround sound, and 2 being the second channel, aka mono. Alongside all those, audio stream players also have a unique signal, finished, which emits whenever the audio finishes playing. Be aware that pausing the audio or toggling the playing variable don't count, and this only emits when the audio stops playing by naturally reaching its endpoint. With all that out of the way, we need to talk about the positional variants of audio stream players, the audio stream player 3D and audio stream player 2D. These share all the same variables and functions of their standard cousin aside from mix target, but in exchange, they've become extensions of the spatial and node 2D nodes respectively, inheriting all of their functionality along with several unique variables, all of which giving them the ability to dynamically dampen their audio based on their position relative to either the center of the camera or the current 2D or 3D listener node. This, of course, makes them essential for creating immersive sound environments. So let's go over these, starting with Audio Stream Player 2D, since it's the more simplistic of the two, having only 3 new variables. The first 2 of whom are max distance and attenuation, both being floats that determine the cutoff point where the audio will be completely inaudible, and dictate how the audio will fall off the closer you get to said cutoff point. Here's some examples of these variables in action with different attenuations. Alright, now what about Audio Stream Player 3D? Well, it trades out volume dB, attenuation, and max distance for a rather large amount of other variables. Though don't be intimidated by their sheer number, really, these can be grouped into 4 categories, where, within said categories, they all work together to fine-tune a single kind of effect. Starting with the first group, these are the variables that collectively dictate how the audio falls off with distance. We'll begin with unit size, a float defaulted to 1 that defines the distance after which the audio will begin to dampen. Then there's unit dB, which is the direct replacement for volume dB and determines how loud the audio will be before falling off past the distance set in unit size. Also, when you get closer to the audio player than the unit size, it can get louder than set in unit dB, with how much louder being controlled by the max dB variable, another float, this time defaulted to 3. After that is attenuation model, the variable that directly replaced attenuation, being another enumeration that controls the shape of the audio's fall-off curve, with 0 being an inverse linear curve, 1 being an inverse squared curve, 2 being a logarithmic curve, and 3 being disabled, meaning that, while still being positional, the audio will never fall off. That is, unless you pair it with max distance, a variable this node shares with its 2D counterpart, but only technically, as despite still being a float, though this time defaulted to 0 meaning it's disabled, it behaves differently, with the prime example being that it controls at what distance the audio player goes into out of range mode, which itself is controlled by a variable of the same name, another enumeration with the default of 0, being mix mode, meaning the audio will continue to play even when outside the audible range, and 1 being pause, which of course pauses the audio when out of range. This can help save CPU resources, but also can be potentially jarring. There are a few additional things to note when it comes to using these variables. Firstly, it's impossible to have attenuation disabled while using max distance. When attempting to do so, attenuation will just be linear. Similarly, when max distance is low enough, it can also override unit size, forcing the audio to fade out sooner. This behavior can be useful for certain situations, like in a horror game where you need precise control of when an enemy becomes audible. Moving on from that, the next category is emission angle. This group of 3 variables causes the audio to be further dampened when the audio player is facing away from the listener beyond a given angle, with the first variable being a simple bool representing if this feature is enabled or not. The second variable, degrees, is a float defaulted to 45 representing the angle. Be sure to remember that this angle is from the negative z-axis. And the final variable, filter attenuation dB, is a float that controls the factor by which the audio is dampened. Within the inspector, these variables are grouped together in the emission submenu. And when being used in a script, all start with emission angle as well. Also, another nice thing is when enabled, there's a little cone gizmo that pops up, making it much easier to fine-tune the angle. Alright, after that is the attenuation filter category, with 2 variables that together constitute a low-pass audio filter that's applied to the audio once you get past the unit size range. With the first variable, cutoff HZ, being a float that sets the frequencies, in hertz of course, above which the filter will affect. And the other, simply called dB, is the factor by which the audio affected is dampened. For those of you who are unfamiliar with this type of audio filter, let's listen to what it's like when used with some aggressive settings. And what it's like when not in use at all. So yeah, the stronger the filter, the more muffled the sound will get. Also, like before, these variables are inside their own submenu within the inspector and all start with attenuation filter when used inside a script. And last but not least, we have the final category, Doppler, with tracking being its only variable. Said variable is yet another enumeration, with 0 being disabled, 1 being idle, meaning the Doppler tracking will be performed on each process frame, and 2 being physics, meaning the Doppler tracking will happen on each physics frame. This Doppler tracking is just the audio player calculating the Doppler effect based on its movement and position relative to the listeners. For those of you unfamiliar, the Doppler effect is how the sound's frequency will increase and decrease as its source moves toward and away from the listener. Here, let me show you an example of it in action. Notice how the pitch of the train horn changed as it got close and then away from the camera. Now compare that to what it sounds like without the Doppler effect. Before moving on, I want to mention that, despite the tooltip and docs saying otherwise, All that's needed for this to work is the player having tracking enabled, regardless of if the current camera does, with the camera's Doppler tracking variable seemingly doing nothing. This effect even works with listener nodes despite them not having a Doppler tracking variable at all, so just keep all that in mind. Now moving on from there, we can go over the audio stream player's functions, which all variations, positional and non-positional, share. Beginning with play, which, well, makes the player start playing audio. It's effectively the same as toggling the playing variable, except for one thing. It's only argument, a float that allows you to specify how far into the stream, in seconds, you want playback to begin. After that is seek, another function with one argument, being a float that sets the current playback position. Again, this is in seconds. And naturally following those is the stop function, which is effectively the same as setting the playing variable to false. Along with those, there's the get playback position function that does exactly as its name implies, and get stream playback, which doesn't give you the audio stream as you might expect, but instead the actual playback object itself. Unfortunately though, the docs and internet itself are pretty sparse when it comes to what you can do with this object once you have access to it, with the only useful info I managed to find being from the audio generator demo linked in the docs, which, as that would imply, shows that this object is crucial for generating audio at runtime. So yeah, take that for what you will. And that's it for the functions. But, as the observer among you may have noticed, there are still two things I've neglected to cover. Those being the bus and area mask variables, which I skipped earlier due to them being what links players to the audio buses. With bus's purpose being obvious, dictating which audio bus the player will send its audio to by default. Area mask, on the other hand, is a bit more interesting, being an integer defaulted to 1 with a range of 32. It is effectively the audio player's collision mask, specifically a collision mask that allows it to detect area collision objects. See, areas have the ability to, if an audio player is inside them and said area is in the same collision layer as said player's mask, override what audio bus a player sends to. This is incredibly useful because, as we'll get onto shortly, audio buses can apply an array of procedural effects to anything streamed through them, meaning you can do things like making footsteps echo when a character enters a cave, for example. I definitely recommend you play around with this when applicable because it can be great for immersion. So now I think it's time we finally move on to this video's final stretch. Let's dive into those fabled audio buses. Starting with where you actually access them within the editor, which is down on the bottom panel between debug and animation. Once open, you'll see the master audio bus, and above it, the title of the current layout. On the opposite side, we have a few options. Add bus, load, save as, load default, and create. Now, this lineup is a little strange because, as you probably noticed, there's a lack of a proper save button, and the seemingly redundant options of add bus and create. Well, firstly, the reason there's no save option is because every change you make is auto-saved to whatever bus layout you're already working on. And if you haven't already created one, the engine automatically makes a default bus layout trest file at the root of your game the moment you make any changes to the default configuration. The create option, on the other hand, is how you can make a clean new bus layout, which you can save anywhere. Keep in mind that the default bus layout will be what's automatically loaded in each time you start up the engine and when you fully compile your game, with other layouts needing to be loaded and implemented in code. Moving on from there, let's go over all the settings within audio buses, beginning at the top with the most obvious, the bus name, with the leftmost being unchangeable and automatically set to master. Down at the bottom, we have the setting that dictates where audio from the bus will be directed to. And again, the leftmost bus is unique in that it's the one that actually outputs to the speakers. Other buses are defaulted to send their audio to the master bus, but can be redirected to transmit to any bus at their left. Back toward the top, there's 3 letter buttons, with S being first. This stands for solo mode, and when enabled, it will mute all other buses aside from the master bus and other buses in solo mode. Make sure to keep in mind that if you put a bus in solo mode that isn't directly connected to the master bus, it'll effectively be muted unless all other buses it's connected to are also in solo mode. Speaking of which, next to that is the M button, which is the mute mode. And beside that is the B button, standing for bypass, which makes all audio going through the bus ignore the effects you have within said bus. And then, to the right of those is 3 dots, which reveals a little menu containing the duplicate, delete, and reset volume options. Don't sleep on the reset volume option, as it's nearly impossible to get volume back to 0 dB with just a slider after changing it. Now moving back down near the bottom, we have the little box where you can add effects to the bus, of which there are 25. There is no limit to how many you can add, and all of them will have a little checkbox next to them, representing if they are active or not. Most of these also have a myriad of settings that can be modified within the inspector after being selected, and are executed in order from first to last. Keep this in mind as it can have a big impact. If you ever want to delete an effect, just right click it and the option will pop up. So this is cool and all, but how do you actually modify audio buses in a script? Well, that's where things get complicated, because you have to do it through accessing the audio server itself, which could be a subject all unto itself, with its massive amount of functions. But don't panic, many of these functions aren't relevant to this video, so we can ignore them. And those left can be organized into 3 groups: layout, bus, and effect, based on their purpose. Let's dive into the layout group first, starting with set bus layout and generate bus layout. The former allowing you to change the current layout to another one you've already loaded on the fly, and the latter creating an audio bus layout object using the current layout. Said object can then be saved with the resource saver through a script like this for later use. Next is another duo, getBusIndex and getBusName, both being very self-descriptive, with the former taking a string as an argument and returning the index of the bus with said name, or -1 if there are none, and the latter taking an integer, returning the name of the bus at that index. Moving on, we have the addBus function, which just adds a blank bus to the server either at a specific index or at the end of the list if either no argument is given or the given integer is larger than what would be the last index. Alongside that is, of course, removeBus, which removes a bus at the given index. And past that is the last layout function, moveBus. This takes 2 integer arguments, the first being the index of the bus you want to move and the second being the index you want it to move to. Note that this doesn't swap the positions of the target bus and the bus already at that position. Rather, it just moves that bus and all the ones behind it over and puts the target in the newly opened position. Also, every single function from this point forward will take an integer representing the target bus's index as their first argument. With that said, let's move on to the bus functions. These allow you to read, control, and change a specific bus's attributes, beginning with the setBusName function, which simply takes a string as its second argument and replaces the given bus's name with it. Following that is 3 sets of functions: isBusSolo, setBusSolo, isBusMute, setBusMute, and isBus bypassing effects, setBusBypass. With each is function simply returning a bool for if the mode is on or not, and conversely, each set function takes a bool as their second argument, which either enables or disables the mode. In that same vein, we have getBusVolumeDB and setBusVolumeDB, which of course return the current volume setting as a float and take a float to set the volume respectively. Alongside these, there's also the left and right getBusPeakVolume functions, which return floats representing the volume peaks on their respective sides. After that is the last function duo in this category, getBusSend, setBusSend. The former returns the name of the bus the target bus is sending audio to, and the latter uses a string to reroute the bus's audio to the bus named. Be careful when using this setter, as it allows you to connect a bus with one further up in the list, which opens up the door to accidental infinite loops where buses end up sending their data back and forth between each other, never reaching the master bus. And with that, we can move on to the last category, effect functions, whom all have to do either with accessing or modifying the effects within a bus, beginning with the very self-descriptive getEffectCount, which simply returns an integer representing the amount of effects within the bus. After that is the natural duo of addBusEffect and removeBusEffect. The former taking an audio effect object as its second argument, with its third argument being able to either be left empty, meaning the effect will be at the end of the list, or be an integer representing a specific index you would like it to go. Bear in mind that you can't just put the built-in class as the argument and expect it to work. Instead, you need a new instance of that class, which can be done by calling the new function on said built-in class, like in this example. Now onto the latter, which just takes an integer as its second argument to target the index of the effect you would like to remove. Also, before moving on, I'm going to go ahead and point out that, like before with the bus index, all the following functions will have an integer pointing to the target audio's effect index as their second argument. So with that in mind, let's move on to the next functions, the duo of getBusEffect and getBusEffectInstance. The first getting a reference to the actual audio effect object at the given index. This can be really useful as it allows you to modify said effect's attributes on the fly. Its newer cousin, on the other hand, which returns a reference to an audio effect instance object, is more narrow in its utility, only being useful in conjunction with the spectrum analyzer effect, as it's how you actually go about getting said analyzed data. Following those is another duo, isBusEffectEnabled and setBusEffectEnabled, whom stick to the trend of being true to their name, with the former simply returning a bool corresponding to if the effect is enabled, and the latter either enabling or disabling it based on the bool put in as its third argument. And now we come to the final argument, swapBusEffects, which simply takes an integer in its third argument to identify the index you want the effect to swap positions with, and, well, swaps the positions of the target effect and the effect at that index. Oh, also, one last thing, the audio server has 2 relevant variables. Bus count, which is just the number of audio buses currently in the server, and global rate scale, which scales the speed at which audio is played. And there we go, all you're likely to ever need to know when it comes to using audio in Godot. Thank you very much for taking the time to watch this video all the way through, and I hope you found it helpful. And also, if you have any advice, criticism, or just ideas for future topics, please let me know down in the comments. And of course, if you want to keep up with my content, don't forget to subscribe. But either way, I hope to see you next time.